our goal is still working with rational exponents. And our goal today is I can apply exponent laws to rational exponents. So first of all, so this is part 3. So recall that all exponent laws apply to rational exponents, and there's more than one way to solve a problem. So I might do it one way, you might see it a different way, but that doesn't mean that either one of us is correct, is wrong. So in other words, if the person in your group is solving it one way, but you see it a different way, and you both end up with the same answer, and you both have used exponent laws correctly, in most cases, it's valid either way you do it. All right, so let's take a look. Okay, so our task, so in other words, the way a question on a test would be asked is to express the following as, first of all, I would want a single positive non-rational power. So in other words, I want my final answer not to have a rational power. Okay, so I want all those 3 things when it comes to a test. So let's see what we have to do that. So simplify and then evaluate. Okay, so this is what we have. And I have a box hidden in here, and it says, usually it's easier to eliminate the rational exponent by changing the base. So remember, we changed the base in part 1. So I can change the base, and usually that will help me get rid of that rational right away. Now you can see, for instance, in this example, a few different things. I already have the same base. Both of them are to the base of 9. So following the rule of multiplying with bases the same, I could go -2 plus 1/2. Now, depending on how well you work with fractions, that would be -1.5. If I changed it then to improper fraction, that would be -3/2. So I could change this question, and I'm going to do it 2 different ways. So the first way I'm going to do is by doing the multiplication. I could go 9 to the power of -3/2. Now what I'm left with is I can change everything so that I can get rid of that rational power. Okay, so it would be that I would have to, oops, didn't mean to do that. I could change now my base of 9, if I wanted to the base of 3 squared. And watch why I did that. The reason I did that is 2 times -3/2 ends up that my exponents, I'm going to have some canceling out here. 2 goes into itself once, 2 goes into itself once, and I'm actually left with 3 to the power of -3. So it actually is kind of cool how that worked. Now, you can see I no longer have a rational exponent. However, I have a negative exponent, so I would have to reciprocate the base and change it to a positive power. Okay, so now if I look back at what they asked me to do, single positive non-rational power, I have that. Now that relies on me being able to add and subtract fractions, which shouldn't be an issue, but we know sometimes it is. So another thing that I could do is I could change both bases of 9 to 2 squared right off the bat. 2 squared, and that's to the power of -2. And I could change 9 to 2 squared to the power of 1/2. And then if I use power to power laws, I end up with 2 to the -4, and it is being multiplied by, notice what happens to this here. This 2 goes into itself once, this 2 goes into itself once, so I'm left with 2 to the power of 1. Then what happens? Multiplying, add my exponents. So -4 plus 1 would be a -3. Notice I get the same at some point. and that equals 2 to the power of positive 3. Okay, so as I said, the second method students usually like better because you don't have to deal with the adding and subtracting of fractions. Right, so let's take a closer look at some of this. So to eliminate the rational, what we do is we change the base so that it is the power of the denominator of the rational. So you can see here, for instance, and what I'm going to do is I'm just going to, in a second, erase. Now, sorry, you already saw what the answer was if you paid really close attention. But what I have is I have 27 to the power of 2/3. So if I want to get rid of a fraction, okay, if I could find something to multiply my 2/3 by, just like I did up here, my denominators will cancel out. So what I choose then is I choose numbers that when I multiply by them, I'm actually getting what I want. So just hold on one second. So back to this question again. So what happens here is if I multiply by the denominator of the fraction I want to get rid of, I end up with 3 times 2/3 in this case. And what happens with that is this is the same as 3 over 1. And you know that I can cancel and I'm just left with the number 2. Okay, so it's much easier to multiply with fractions than it is to add or subtract. So the same thing is true here. What do I want to change 81, the base, so it's to the power of 4? Because if it's to the power of 4, I can cancel out the 4's and it makes life easy. So 27, something to the power of 3 equals 27. Well, hopefully you recognize that 3 cubed is the same as 27. And what about 81? Something to the power of 4 equals 81? Well, that's 3. Okay, now how do I get those numbers? Well, if I know my multiplication facts very well, it actually is not that hard. However, if I didn't, I could take my calculator, I could go 3 to the power 2, 3 to the power 3, 3 to the power 4, until I got the base that I originally had. So let's take a look at some more examples. Okay, you can see now they have become a little more complicated. So you can see in this case I have bases of 8. However, the bottom, the denominator one, has a rational power. So I want to get rid of that rational power, and the way that I do that is I want to change 8 so it's something to the power of 3 so that it will cancel out with the 3 denominator of the 2/3. So what would that be? Well, hopefully you recognize that 2 cubed is the same as 8. So if I put a 2 here, I haven't changed the value of 8. 8 is 2 cubed. Okay, and since I know I have to have a single power, I'm going to change the 8 in the numerator up here also to 2 cubed, and that is squared. Now it's very easy to finish solving this. This is going to be 2 to the power of 6. And in the denominator, we can see what happens here is it's going to cancel out our 3's, to a 1 and a 1, and I'm left with 2 squared. Okay, now my bases are both the same, and I'm dividing, so I subtract my exponents. So that's going to be 2 to the power of 4. So it's a single power to a positive, non-rational exponent. Okay, so let's go and try the next one, and I'm just going to move it over on my page just because it makes it easier with my writing with my tablet. Okay, so again, what's going on here is I have a denominator of 3, and I need to change my 27 somehow, so that it is to the power of 3. So what I'm thinking in my head, and I'm just going to, as soon as this stop flying around on me, I want to change 27 so it is something to the power of 3 because of the 3 here. Okay, so I know that 3 cubed will do that for me. So I'm going to change my 27, my number 27, to 3 cubed, and all of that is still to the 2/3. Now, when I look at my denominator, in most cases, it will also be the same base as the top one. Not always, though. So I'm looking at 81. I want it to be something to the power of 4. And that would be a 3. So 3 to the 4th equals 81. And in this case, 81's to the -1/4. And the next step is actually quite easy. So what we're going to do is we are now going to cancel. 3 goes into itself once, 3 goes into itself once, 4 goes into itself once, 4 goes into itself once. And if you notice, by doing that, we've eliminated having to really work with rationals. So I end up with 3 to the power of 2 and 3 to the power of -1. I'm dividing. I must subtract the exponent, so that's going to be 2 take away a -1, and you know that that's going to be a +3. So I end up with 3 cubed.